It's some time. Go away, why don't you leave me alone? That's because it's my brother, Shadow. Whether we are standing out in the sun or next to a light source, our body does not let any light pass through us. Nah. So what happens? A dark patch forms in the area where the light does not reach. The dark patch is called a shadow. Why do things rust? When iron comes in contact with oxygen and moisture, it forms a reddish-brown compound called hydrated iron oxide or rust. This process of rusting eats up the iron and reduces its strength. It can be represented by the following equation. Iron plus oxygen plus water gives rust or hydrated iron oxide. Hi! Today, I have an interesting challenge for you guys. Take 2 books and interleave their pages like this. Now, try to pull and separate the books. Arg! Why can't we separate the books? Due to the force of friction. It acts opposite to the direction of motion. So when I pull or move the book in this direction, friction acts in the opposite direction. This prevents the pages and books from separating. Where's my key? Where's my key? Can't seem to find my key.
Oh.
Awesome some. This guy over here is a magnet. A magnet has the property to attract other objects made up of iron, cobalt, or nickel. Want to see something? So cool, right? This area formed around the magnet is called a magnetic field. Go away! Now you're troubling the flower. Buzz, buzz. Hold on, I think the bee is helping it. Some male flowers have pollen grains tightly packed in their anthers. The bumblebee's buzzing creates vibrations. These vibrations spew out the pollen grains all over the bee. As the bee flies from flower to flower, some pollen grains fall onto the stigma of female flower. This act of transferring pollen grains is called pollination. Wow! Who's this guy? Handsome looks, great personality. It's awesome some. I can see myself in the mirror because of reflection of light. When light from our body falls on a shiny, polished surface like a mirror, it changes the direction of light and reflects it back to our eyes, making us see ourselves in the mirror. This change in the direction of light is called reflection of light. That's north! That's north! I lied. This is north. How do I know? Easy peasy, because of this magnet. Place the magnet on a cork, then keep the cork in a bowl of water. Look, the magnet is rotating! When it stops, the north pole of the magnet points in the north direction. So, our magnet acts like a magnetic compass, helping us with directions. Save yourselves! Save yourselves! The sun is disappearing! Relax. It is getting dark because of the solar eclipse. We get light from the sun. Now, sometimes the sun, earth, and moon come in a straight line with the moon in the middle. So the moon blocks the sun's light. Thus, the shadow of the moon falls on some parts of the earth, causing darkness. Arg! Now, just wait and watch. I'm coming. It's pointless. No matter how hard I try, the great gravitational force will never let it happen. We are all governed by an invisible force of attraction called gravitational force. It helps us walk on the ground and ensures that what goes up ultimately comes down. Ow! Ow! Wicked nettle plant! You injected methanoic acid into my skin! Haha! Your neighbor, the dock plant, contains basic chemicals. It'll save me! How? When an acid and base react, they cancel the effect of one another and form salt and water. This is called neutralization reaction. Depending on the strength of the acid and the base, the resultant product is either neutral, acidic, or basic. Let's race! Yeah! I won! How? With displacement. The actual path length traveled by a body is called distance, while the shortest distance between the start and end point is called displacement. If moving along a straight line, both distance and displacement are equal, say 2 miles. But if we return to the start point, distance equals 4 miles, while displacement becomes 0. Why? Because the start and end points are now the same. Come on, getting close. Did I just use the first law of reflection? Let's draw a perpendicular called normal. This ray is the incident ray, and this is the angle of incidence, while this is the reflected ray and the angle of reflection. According to the first law of reflection, angle of reflection is always equal to angle of incidence. It can be represented as angle I is equal to angle R.